Rule-based sentiment analysis is easy to understand and implement, but it is not always that accurate. Modern sentiment analysis often relies on transformer models, which represent a major step forward. Transformers are based on deep learning and are designed to capture how words influence and relate to each other, even when they appear far apart in a sentence. Transformers are crucial because they understand context. Instead of looking at words in isolation, they recognize how meaning changes depending on surrounding words. This allows them to handle complex sentences, subtle tones, and even sarcasm much more effectively than rule-based methods. Going into detail on how transformers work is a little out of scope for this course. For now, we will cover transformers at a high level and see how the code works. To apply transformer models for sentiment analysis, we start by importing the transformers library. From it, we bring in the pipeline function. This function provides a quick way to use powerful pre-trained models without needing to build them from scratch. We then call pipeline function with the argument sentiment analysis to return an object which will act as our sentiment analysis tool. By assigning it to a variable, for example, sentiment pipeline, we store this tool so we can reuse it to analyze any sentence we pass to it. When we run this code, you may see a message saying that no model was supplied and that a default model will be used. This is nothing to worry about. The pipeline automatically loads a reliable pre-trained model for sentiment analysis. The message is simply a reminder that in real-world applications, it's best to specify the model yourself. For our purposes, using the default works perfectly fine. You might also see the line, device set to use CPU. This just means the model will run on your computer's processor instead of a GPU. It might be slower, but it will still work correctly. Okay. The next step is similar to what we've done with the rule-based sentiment analysis. We print the first sentence and call the sentiment pipeline object with the text as input to receive the score. We see that sentence 1 is identified as positive with a score very close to 1. This indicates that the model is highly confident that it's a very positive sentence. Transformer models return both a label, positive or negative, and a confidence score between 0 and 1, which shows how sure the model is about its prediction. So eventually you may see a positive score like the one here and a negative label, meaning that the transformer is very confident at that score. That's the case with sentence 2. Sentence 3 is also given a negative label with high confidence. Sentence 4, however, is labelled positive with a strong score. This is unusual because rule-based models typically see sentence 4 as neutral. In this case, the pre-trained transformer model has misclassified the sentence. Interesting, right? So, what can we do to improve the results? One option is to use a different pre-trained model. There are many models available, each trained on different datasets and with different parameters. For example, we can choose a model trained specifically on English tweets to see if it performs better on our sentences. To do this, we once again use the pipeline function, but this time we provide not only sentiment analysis as the task, but also the name of the model we want to use. Since a wide variety of models are available online, if the default model doesn't perform well, it is a good idea to try others listed on the Transformers website. When we run this code, you may see a message saying that the emoji package is not installed. This simply means the model cannot convert emojis or emoticons into text, which may slightly affect results if your data contains them. For our examples, this makes no difference, so you don't need to worry. If you ever work with text that includes emojis, you can easily fix this by installing the package as suggested. Once the specific model is created, the code to run sentiment analysis stays exactly the same. For example, printing sentence 1 and passing it through the model gives a positive score. Sentence 2 is classified as negative, but with lower confidence, showing some nuance. Sentence 3 is identified as positive, again, reflecting nuance in interpretation. Finally, sentence 4 is correctly recognized as neutral, with high confidence. So, by switching to a model that is better suited to our use case, we achieved more accurate results in sentiment analysis,